Hello guys, in this slide I'm going to discuss with you sine rule. Under this we are going to talk about the derivation of sine rule and application of sine rule to solve numerous problems in trigonometry. Okay, first of all, what is sine rule? The sine rule states that the sides of a triangle are proportional to the sine of the angles opposite to the sides in question. What this is talking about is this angle here is proportional to the opposite side, which is side A here. That is the side that is facing it, which means that A over sine A is the same thing as B over sine B, which is the same thing as C over sine C, and that is the sine rule. But how do we come about this formula? From the triangle XYZ here, if we separate the triangle, this equilateral triangle, if we separate it into right angle triangle, we are going to have two right angle triangle in it like this. We are going to have this one as our Z, our O, our X, and likewise from this side we are going to have another triangle, which is another right angle triangle, which is our Z, our Y, and our O. This is angle A and this is angle B. This is side B and this is side A. If we use SOHCAHTOA, we have sine of this angle A, sine A. Sine of that angle A is going to give us A equals to, remember it is opposite over what? Over hypotenuse. Our hypotenuse here is B. Our opposite is this, which is H, which is opposite over hypotenuse, which is H over B. Then the same thing here too. If you make using SOHCAHTOA rule here, for sine of this one we have sine B equals to H, which is opposite all over hypotenuse, which is A. Making H the subject from each side, we are going to have from this one we have B equals to, okay, B sine A equals to H. From this one too, by cross multiply, we have A sine B equals to H. Then we equate H to H. If H equals to H, we are going to have the first one here equals to the second one there. And by doing so, we can rearrange from this place. This is sine A equals to H over B, where H equals to B sine A. From this one too, we have sine B equals to H over A. Cross multiply, we have H equals to A sine B. Equate H equals to H, we have A sine B equals to B sine A. Then, if we divide all through with sine B, we are going to have A equals to B sine A divided by sine B. Also, if we divide all through with sine A, we have A divided by sine A equals to B sine A divided by B divided by B. Therefore, we are going to have A divided by sine A equals to B divided by sine B. Similarly, A divided by sine A equals to B divided by sine B equals to C divided by sine C. And that is what we call sine rule. That's sine rule. Which means that at the end of this first period, my students should be able to derive sine rule by the use of the suitable diagram, the one I use, this diagram. You should be able to derive sine rule, and that is that concern. Okay, second period objective. At the end of this second period, you should be able to use this sine rule to determine angles in triangle and to determine sides of different triangle. Let's solve examples. Example 1 now. Example 1. Question 1. In a triangle ABC, A equals to 60 degree, C equals to 75 degree, and BC equals to 4 centimeter. Find AC. Solution. Since the total angles in a triangle is 180 degree, therefore we need to find angle B. A plus B plus C equals to 180 degree. Then we have angle B2 equals to 45 degree. Then we can now use our sine rule. Remember, sine rule states that A over sine A equals to B over sine B, which is the same thing as C over sine C. Our A equals to line BC, our B equals to line AC, and our C equals to line AB. Then if you substitute this into the formula, we have B over sine 45, which is angle B, equals to A over sine A, which is 60 degree, and our A is 4 divided by sine 60 degree. If you press the calculator, we have our B equals to 2.82, which is approximately 3.26, which is approximately 3.33. Example 2. In triangle PQR, P equals to 120 degree, Q equals to 45 degree, and QR equals to 5 centimeter. Calculate PR. Solution. Using sine rule to find PR, we have PR over sine 45 equals to QR over sine 120 degree. Making PR the subject, we have PR equals to QR sine 45 divided by sine 120. Then our QR is 5. Sine 45 is 0.707 divided by sine 120, which is 0.866. Then our PR equals to 3.535 divided by 0.866, which is 4.1 centimeter. Example 3. In an acute angle triangle ABC, in which AB equals to 3 centimeter, AC equals to 6 centimeter, and angle ACB equals to 20 degree. When you are given angle ACB, they are talking about the angle is on C. That is, if we have a triangle ABC like this, ABC, our AB is 3 centimeter. 3 centimeter is here. Our AC is 6 centimeter. 6 centimeter is here, and our angle ACB is here, which is 20 degree. Then I say find angle ABC. We are looking for this angle here. Then using sine rule, since this angle B is facing 6, this angle C is facing 3, we have 3 over sine 20 equals to 6 over sine angle B that we are looking for. Then we have sine 20 to be 0.342. Then we have sine B equals to 6 sine 20 divided by 3, which is 6 into bracket is 0.342 divided by 3, and we have our sine B equals to 0.684. Then we find the arc sine, shift sine of 0.684, which is 43.14 degree. Example 4. QRS is a triangle with QRS. We have QRS is a triangle where our QS is 12 meter. Our RQS is 30 degree, and our angle QRS is 45 degree. They now ask us to calculate line RS. Find this line RS. Therefore, we use 12 over sine 45 and S over sine 30, which is RS over sine 30 equals to 12 over sine 45. Then our sine 30 is 0.5, our sine 45 is 0.5, 0.707. Then you press the calculator, we have our RS to be 8.486, which can be approximated to 8.5 meter. Example 5 now. Example 5. Question 5. In a triangle QPR, draw the in triangle QPR is a right angle triangle. Therefore, the triangle they are talking about is a right angle triangle. First thing, you draw a right angle triangle, and they are talking about QPR. Okay, PQR. PQR. Then it is stated that QPR, that is this angle P here, is 30 degree, and angle QSR. Therefore, it means that there's another straight line here where this place is S. Then we have angle QSR, which is what? 60 degree. It is 60 degree. If PS, line PS is 20, this place to this place is 20 meter, then I ask you to calculate QR. Find this place. Find this place, which is QR, which is the height of that triangle there. The first thing you do is, since this place is 60 degree, find this place. Remember that this place is angle on a straight line. If you remove 60 from this place, therefore this place is 120. 120 plus this one will give you 150. If you remove it from 180 degree, you have this place, which is 30, which is 30 degree. Therefore, this place is 30 degree. That place is 30 degree. Then you can use sine rule for this place and this place to find this place and this place. Therefore, if you use sine rule for that, we have this place to be what? 20. 20 is facing angle 30 here. This place is facing this 20 here. This place is facing this place. Therefore, you can use this place to find this place, or you use this place to find this place, anyone you choose. Then if we use this place, we are looking for this place now as y. We have our 20 over sine 30, 20 over sine 30 for that one equals to, this place 2 is 30, y over sine 30. If you rearrange it, you do the necessary cross multiplication, we have 20 over sine 30 equals to y over sine 30. Therefore, our y equals to what? 20. Because this sine 30 will cancel this sine 30. This one cancel this one. Therefore, you have our y, which is this place, which is QS, to be 20. If QS is 20, you can use the SOHCAHTOA rule to find this height here. This place is 60, and it is opposite to this x we are looking for. We can have sine equals opposite over hypotenuse, which is sine. Sine 60 equals to x over 20, and you have your QS, which is x, to be 17.3. 17.3 if you use that relation. And that is that concerning the slide for today under sine rule. This is your assignment. Do the assignment and submit through the normal platform. When we meet online, I'll do more explanation on the classwork. Thank you.